You know, when the event organizer gave me the 8:30 a.m. morning slot, I told her, isn't that a bit early for folks? I mean, especially with the daylight savings? She said, no, it's not early. Matter of fact, there's gonna be a huge crowd. So I'm so glad to see all 10 of you here this morning. Now here's a quick test to see if you're addicted to technology. Do you find yourself taking a selfie during a 10-alarm fire? Does your boss at work tell you to stop flying that damn drone in the conference room? Or do you believe that you're a cyborg because you wear 1,000 wearables on your wrist, neck, chest, and head? If you've answered yes to any of those questions, you're at the wrong conference. Go to the nearest Star Trek convention, it's right across the street. All right, now some of the best research firms indicate that by 2020, that there will be 999 trillion connected devices from here to the next galaxy. And that fitness bands will make hundreds of dollars in sales. And we know that the public is starting to embrace wearables when a 100-pound bracelet makes it into a rap video. So let's talk about today's talk here. So what I want to cover with you today is how does emotion play into our decision-making process, our behavior? And why does the current market research tools miss the mark in terms of being able to detect and classify emotions? And how new sensor capabilities is providing a new world in terms of the ability to be able to measure and quantify emotions. And finally, the role of machine learning in regards to being able to provide accuracy and prediction in terms of the detection capabilities. Now, we humans like to believe that we're rational, right, when it comes to decision making. We use hard, quantifiable facts and figures. But in reality, we're sentient beings. We make decisions and perceive the world through the lens of emotions. Now, I know some of you seem a little bit quizzical about that because you believe that you're an object-oriented humanoid robot. Am I right? Well, let me tell you something. What's the reaction here? Did you find yourself saying, ah, to that baby photo? Or perhaps surprised by the new and improved David? Well, the thing is, emotions are really powerful, so powerful that they drive our decisions from homes, cars, to the people we should marry. But the problem is that today's capabilities is limited. So a lot of companies and market research firms are still fundamentally not able to understand the response, the emotional response of our consumers. They don't really understand how consumers perceive our brands. And at the end of the day, we're still using antiquated, generic tools to assess the user response. As an industry, we're still using broad industry sweeping surveys such as this one that ask questions such as, how satisfied were you with Hotel X? On a scale of 1 to 10, how would you rate the coarseness of your bath towel? Right? How lightning slow was your internet? And for your next visit, do you prefer a room next to the elevator, ice machine, or the smoking area? Online, we use sentiment analysis to be able to analyze tweets, social chatter, and emoticons. But you know, even with all this sophistication, you essentially get binary feedback, positive or negative. So at the end of the day, we still don't really know how consumers really feel about our products, do we? Emotions are not black and white, positive or negative. Human emotions, as we know, are immensely complex, as you can see by this chart of primary emotions. They range from love, optimism, awe, disapproval, aggressiveness. Speaking of, if you have a teenager, you know what it's like to experience all those emotions all in one day. So how do we measure emotions? Well, first some basics. According to research, 55% of communication is based on body language or tone of voice. And then only 7% is the actual words spoken. Body language comprises of aspects such as our postures, or gestures, eye movements, head movements, expressions. Affective computing, not infected computing, is a field of human-computer interaction that studies and interprets and recognizes and simulates human emotions. Affective computing is an interdisciplinary field that spans across computer science, psychology, and cognitive science. And with the advent of ubiquitous computing and wearables, we're starting to be able to measure physiological parameters through sensors, right? Such as EEG, ECG, EMG, body impedance, galvanic skin response, heart rate variability, blood volume pulse, breathing rate and volume. So this in turn, when used in conjunction with your body language, tone of voice, and the actual words spoken, can begin to start to help provide insights about how consumers feel. What is their mood? What is their attention level? What is their stress or anxiety? And when affective computing is layered with artificial intelligence and machine learning, it begins to help us better detect and classify with accuracy and predictability. Wearables provide new dimensions of context, geolocation, biometrics, behavioral pattern. You can say that Leonard Keeler, the inventor of the polygraph or the lie detector, was a pioneer in this space. Invented back in 1924, this instrument called the emotograph could detect if you were lying or telling the truth by being able to measure your pulse, your heart rate, your breathing, and your sweat. Now, of course, these days we take the polygraph for granted. We regularly use it on our kids when they borrow the car, right? Or when they come home late. But wristbands, we know Apple Watch is coming out, fitness bands, clip-ons, wearable jewelry. These are starting to provide new basic sensor capabilities, such as temperature, movement, heart rate. And we know that we can anticipate much more sensor capabilities. Matter of fact, I'm working with a company that is bringing to market the ability to actually detect heart attacks and stroke before it happens. Now, these sensors provide rich health data that can start to chart the emotional response of users. Of course, there's some questions about the medical grade, but I have some comments about that too. EEG sensors. These measure your brain waves. Okay? Companies such as Emotive are working on not only trying to measure electrical activity in your brain, but also developing capabilities to extend mind control through these headbands. This is the future of human-computer interface. Now, the problem for me is that I'm not very good at reading minds. Part of the reason I was motivated to get into the field of emotion sensing is because I can't seem to understand my wife. She often says to me, just perfectly out of the blue, she'll say, well what? What are you going to do? Do what? Well, I just told you. I didn't see your lips move. Well, you're just supposed to know. We've been married for 17 years. So now you see why. By the way, I told that joke to my wife, and she said, that's not very funny. Now, space and physical environments, and we're talking about beacons, camera technology, and more broadly, the Internet of Things. Now, these are actually starting to provide insights around how we interact with the physical world in regards to objects, buildings, and the dimension of space. Now, one of the things I love about being in this industry is that I get to work with some of the most amazing technologies. And Philip over here, he knows, you get to work with some of the greatest technologies, right? Well, just the other day, we ran out of bandages, so I used a wearable tattoo computer. I used a 3D printer.
A wearable what?
Tattoo computer. Bear with me.
I just wanted to not let you like slip over it.
Yeah, you're good. You're actually really good. I used a 3D printer to replace my mother-in-law's fruitcake, which, by the way, is exactly the same. And I used a robotic arm to spank my kids. And I replaced my dog's lazy eye with a 180-degree camera. And now it dreams in 3D virtual reality. How we sit, stand, walk says a lot about how we feel. Matter of fact, there's a company that I'm working with called Alice Wearables, based out of Austin, Texas. They're trying to crack the body language code. So right now, their current algorithms are able to interpret the difference between a push-up versus a burpee. Why? I don't know. But they aspire to be able to bring intelligence into body language and movements. So that one day we can actually understand what is their context, what is their energy level, what are they trying to accomplish from an intent. Facial expressions, very important, powerful aspect of our body language. It cuts across race, culture, gender, language. It's a powerful indicator of your emotions. Your facial expressions using the facial action coding system, or FACS, is used to be able to detect and classify emotions. FACS is an index that uses a taxonomy of human facial movements. And emotions are derived from the action units, or the action of the group of muscles, okay, when all these things move up and down. And action unit codes are classified under main expressions, eye movements, head movements, visibility, and general behavior. Now, unfortunately for me, as you can see, FACS doesn't work, because apparently I don't have emotions. I don't know if you picked that up or not. I had a college mentor who once told me, Scott, I know that you're a super enthusiastic guy, even if you can't see it. Thank you, Sterling. Companies like...
You're gonna smile.
One second. Companies like Emotion and Inviso are putting the science behind facial expression recognition to be able to automate the detection and the classification of primary emotions, such as joy, surprise, and anger, as well as advanced emotions such as frustration and confusion. Let's move on to eye movements. And I'm moving very fast, or maybe I was trying to slow down. You probably noticed that when you speak with certain people, they tend to look up, down, or to the side. Well, it turns out there's actually science behind your eye movements. Depending on the direction of your eye movements, you may be trying to recall or construct an image or a sound. Or perhaps you're recalling a touch, taste, or smell. Or you're just thinking hard about something. Now there are, of course, the non-verbal cues, such as squinting, gazing, eye blocking, that make hints at hidden emotions and intent. So maybe there's some truth about being aware of those people with shifty eyes, after all. Google has filed Google Glass patents for eye tracking to be able to determine the pupil location in relation to the image that they're looking at. Okay. So that it can be used as an input mechanism in lieu of gesture or touch. And we know that this is going to be an important feature in VR glasses. But more so, beyond just control, but as a way to determine the emotional state and the response of users as they consume entertainment and gaming content. Speech, or speech rates, pitch, intensity, vocal variability says a lot about how we feel. Matter of fact, our emotions have a huge impact on our speech as it modulates our respiratory system, our heart rate, our blood pressure, our larynx, vocal tract. And changes in a speaker's autonomic nervous system can account for some of the biggest significant impact to speech. So for example, when you're in a state of fear or anger or joy, your sympathetic nervous system is aroused. This in turn induces a rise in your heart rate, heightened blood pressure, changes to respiratory movements, greater subglottal pressure, and muscle tremor. And the resulting speech is faster, louder, higher frequency energy, higher average pitch, and wider pitch range. Now this may explain why I sound the way I do when a soccer ball hits me right between the legs. Now Beyond Verbal is working on using their expressive speech technologies to be able to decipher and to interpret emotions. There's an older version of the PowerPoint online that you can download, so you don't need to take photos. Let's move on to tears. Turns out tears are pretty complex. I think I've only cried once in my lifetime. Well, it turns out the chemical makeup of tears is different depending on how you feel. And there are many triggers beyond just triggers of joy and sorrow. Rosalind Fisher published her topography on tears, where she studied over 100 different tears using a microscope, magnified at 100x and 400x. Her thesis was that your emotions produce different tears. What this study showed is that tears, which is comprised of water, protein, minerals, hormones, antibodies, and enzymes, are dramatically different depending on the emotion that you have at the moment your tears are shed. And you can see that even the structure is different. And here are just 3 examples out of 100. Now, of course, for us guys, we only have one type of tear, right? The kind of tear that we shed when our team loses. Now, for the time being, there is no commercially available technology that can decode tears, the emotions in tears. However, looking at the Google contact lens as an example, we can anticipate that in the future, such a capability can be built. Neurochemicals. Now we're getting at the chemistry of emotions. You feel what you feel because of these neurochemicals at work. They determine your state of happiness, your bliss, your depression, your anxiety. Neurochemicals, or also called neurotransmitters, are endogenous chemicals that transmit signals across a synapses from one target neuron to another target neuron. And neurotransmitters are classified under things like noradrenaline, serotonin, melatonin, dopamine, and other systems that you see here. And these neurotransmitters regulate everything from your anxiety level, your wakefulness, your cognitive control, your hunger, your mood, your arousal. These are powerful indicators of your emotions. But unfortunately, for the time being, there are no non-invasive techniques to be able to extract neurochemicals from your brain, unless, of course, you're willing to volunteer. All right, so I went through a lot of material, but I wanted to make sure that we had enough time for some Q&A. So each of these areas that I share with you, just real briefly, requires their own separate sessions. And there's a study or subfields within them. But I wanted to just pause here to talk about some of the limitations, constraints, and concerns. Now, you probably noticed by now that one of the biggest dependency is sensor development. And you saw that, particularly with the last two areas that I shared with you, which is much further out, but very powerful nonetheless. The other aspect is that the dimension of affective computing really needs to be tuned for context. In other words, how you implement for your home, for your car, for work, and public spaces is going to have to be different. The way you want to look at this is that it's really a toolbox where you pick and choose selectively the right tools and capabilities for the job. Now, using one dimension of affective computing can be very limiting. For instance, the drawback of using voice analysis as a standalone is that it's difficult to get conclusivity on an emotion. And of course, whenever we talk about wearables, we have to address consumer privacy and security. I mean, these are massive undertakings that require discussions and work at the industry standards level, and as well as by your company's privacy policy. Now, for solutions that we build, we employ privacy by design from end to end. Moreover, we also use PKI or digital certificates on devices to ensure UDID authentication. And we take these things very seriously. Recognizing emotional information requires meaningful patterns from gathered data. Now, the way we do this is we use machine learning. Now, process different modalities, some of which I share with you. Facial detection, speech recognition, or natural language processing, as an example, to be able to detect and classify emotions. Machine learning models, or machine learnings, operate by developing models using training data, and use that to be able to make intelligent decisions as well as predictions. And machine learning helps you to be able to refine and optimize your modeling with its algorithms. And it helps you with intelligent decision making, such as, is this relevant or not? How do you rank the relative importance of variables? It also helps automatically modify, self-modifies. It's constantly optimizing for accuracy and best fit. Now, matter of fact, our agency is spinning off a venture startup to pursue this very opportunity. We're currently speaking and working with some of the largest brands across North America and Asia. Very large, and I'm sure you are very familiar with some of them. And we're looking to launch later this year. If you're building a wearables or IoT solution, come and speak with me, because we're building one of the broadest integrated solution that's going to aggregate across devices and nodes. And the value to you is a brand new revenue stream, in addition to selling your hardware or solution per unit. All right, so let's recap. So I went fast, fiercely, with intent. Human beings make decisions based on facts and figures, but also on emotions. that we talked about, unless of course you're a cyborg. The affective computing framework provides another dimension in addition to the traditional market research methodologies and tools. And when it's appropriately applied, it starts to give us deep insights about how consumers feel about our service, our app, our products. And finally, we need to move away from irrelevant messaging. Our systems need to understand and be smart enough to know what they want when they want it. And users will come to expect this. And that's why you need to use affective computing with machine learning so that you can start to drive deeper insights around consumer insights and their feelings and emotions. To be able to gauge and have deeper connection and interaction. And be able to deliver more precise on-target messaging. So whether you're building enterprise app, consumer app, or B2B, or any of that sort, this is fundamental. And you are starting to see this at the ERP level. We're in conversations with Oracle, SAP, IBM, becoming very important. So, on that note, you have no excuse for not being able to read your spouse or significant other, all right? So good luck. Thank you.